number 2, and for recording number 2, it's going to be the second homework problem. For this information, the idea is to keep a good outline on for things, so it's going to be the second homework problem that you had. It was the question of this Yerkes-Dodson law. Drew, are you familiar with that idea, the Yerkes-Dodson?
No.
Beverly, were you familiar with that idea? So
Kind of, but not like a ton.
So if you look at your notes and outline, the Yerkes-Dodson law was developed a long time ago. It basically said the idea that if a task is really simple, if a task is really simple and you increase people's arousal from low to medium to high, you'll get increased performance. But if a task is really complicated and you increase arousal, at some point that arousal might be too much. And if you have a really hard task and a person is, drinking tons of Diet Cokes and coffee and over-aroused, performance might actually go down. So I created a data set here, and probably the best thing to do with the data set is to look at the cell means. Beverly, do you have that homework problem too with the cell means there?
Yes.
So if you look at the cell means when the task is easy, Emily, how does it look like when the task is easy? And Drew, do you have that as well?
Mm-hmm.
How does it look like, and let me even ask Drew here, how does it look like performance was when the task was easy and you went from low to medium to high?
It looks like it's the same. Or am I not
Well,
seeing that right?
When it's easy, it's not quite that page. It's at the bottom of the previous page.
Oh, there we go.
Do you have it?
There we go. Yep.
When the task was easy,
The numbers are higher.
Yeah.
It's difficult.
yeah, it looks like when the task was easy, performance went up, but when the task was hard, what happened? It kind of went up at first, and then what happened at the end?
Way back down.
So statistically, that's probably going to be a significant interaction. Emily, can I ask you how many independent variables here?
There are 2.
2. What are they?
They are arousal level.
That's right. Easy versus, arousal level, low, medium, and high. So that's 3. So it's a 3. And then what's the other one?
Difficulty.
Task difficulty. So it's a 3x2 or 2x3 design. And everybody's only tested once. So this is a 3x2 type of design here. And we have all of these people. Now if you look at the next page, once again, the idea is how many statistical effects can we look for? We can look for 3. Is there a main effect of arousal? Is there a main effect of task difficulty? And is there an interaction? We're almost predicting here, because we looked at the cell means, that there will be what, Drew?
That's a significant difference.
Yeah, and a significant interaction in this case. So the way we would actually put the data in, I actually have on the next page, we actually have, Beverly, a data screen. Can you guys kind of see the data screen? You have the printout, Beverly, which will be just fine. Can you see what I kind of created there? So I didn't want to waste time creating this in class. Let's actually go over and see if Miss Emily can be in charge of this. Emily, can you help us do the steps here? Let's do the ANOVA. And why don't you give Beverly the steps to use here? Tell her what you're going to do first. I got to take my glasses off. Analyze. That's right. And
Compare.
not quite. General linear model. And Drew, if you want to write these down, this could be good. General linear model. Likewise for you, Beverly. Univariate.
Univariate.
So reset this, Emily. Go to the bottom and reset it. What's the DV now?
The DV.
I creatively called it what?
DV2.
Yeah, I have something called DV2. and Emily, what are the two? You always put the factors into fixed 2. What did I call the first one, Emily?
Task difficulty.
Yeah, so the fixed factors are task difficulty and arousal, and then you have to do options.
And then options.
And put the 3. Yep. We're putting the 3 effects in and do continue. Write it down if you want, Em, in your notes. And we do okay. And that just saved about an hour and a half. You believe us, don't you, Beverly?
Yeah. It took me a really long time to get used to SPSS when I was doing it. I was like, how do I do this? And yeah.
So the key screen at the end of this, I actually have on the handout. So we can just look at this as kind of the key screens. So once again, and let me even ask you, Drew, does it look like we have any important effects here?
Yes.
Yeah, everything kind of looks significant here. What are the 3 effects, Drew, we could actually be looking for here?
You're looking for the task difficulty effect, an arousal effect, and then an interaction between the two?
That's right. Is there a main effect of task difficulty? Is there a main effect of arousal? And is there an interaction between task difficulty and arousal? So you can ignore the intercept and corrected model. They're not important here. It looks like if we go across for task difficulty, we got a sums of squares at 120. That number will be large if the marginal means are large. And so the question is, what marginal means are we using for task difficulty? Emily, what were the 2 levels of task difficulty?
Easy and difficult.
Yeah, and the 2 means for that were what?
6 and 2.
So this is very important for your notes. The more those 2 numbers are different, the bigger. The more those 2 numbers are bigger, the greater the sums of squares will be. They're feeding directly into the sums of squares for task difficulty, the 120. If those numbers are really different, that
Which
number will be
numbers?
large. The 6 versus the 2. The more different they are, the larger the 120 will be. Beverly, does that make sense for you?
Mhm.
And Drew, is that
Yeah.
working? So that's really important to know. And we have 1 degree of freedom, because how many categories of task difficulty do we have? 2. So you'd want to put this in the notes as well. And then we've got, what, the 4,800, oh, I'm sorry, the 120 for the mean square. How does 120 turn into 24? Beverly, any idea how 120 for the mean square turns into 24?
Take the sum of squares. I'm sorry. You take the 120 and then you put it over the mean squares for the error, which is 5.
Exactly. The 120 over the 5. That's always the denominator. 120 over 5 is 24. Emily, is 24 significant? Is 24 significant, Emily?
Yes.
Yes. How would we write that out? Drew, how would we write that one out for the main effect of task difficulty?
Not sure. I didn't get that.
Okay. Beverly, can you help out a little bit?
Sure. Main effect for task.
For task difficulty, it would be an F.
F 1,
1, comma,
comma. Would it
go ahead.
be the 30 or the 24?
The 24. Exactly. The
24,
24 equals 24 for the F
24.
obtained. Then P would be what? Emily, what would be the P here? How would you write out if F was 24? How would you write out that in
P
AP?
less than 0.001.
There you go. Less than 0.001. Statistically significant. So 1 main effect there. Emily, is there a main effect for arousal here?
Yes.
Yes, there is. And once again, the screen gives you the 2, 5, and 5. When arousal is low, it looks like performance is low as well. When it's higher, it's a little bit better. So you would write that out. Drew, can you figure out how you would write that one out now?
The arousal?
Yeah.
I think you do F and then 2?
2, because there are 3 levels of arousal, and then it's f of 2 and 24.
Where does the 24?
That's the error. That's the denominator.
Okay, got it.
And then that equals an F score of 6. Then how would you write that one out?
P is equal to 0.008.
008. Significant. When arousal is higher, performance was better. And finally, and most importantly, the third one. Is there an interaction? Emily, does it look like there is an interaction? Between task difficulty and arousal, does it look like there's an interaction?
No.
Why do you say no?
Because none of
No,
the
gotta
numbers
look
are
up here.
matched.
Is there a significant interaction between task difficulty and arousal?
Um,
0.008.
0.008.
Yes,
Yes.
there is. So an F of, once again, 2 and 24 equals, it looks like 6, P less than or P equals 0.008. And for that one, what would be our real world statement? Beverly, what would be the real world statement for the interaction there? Think back to how I defined the Yerkes-Dodson law. What did I say?
Yeah. That the
If the task if the task was easy, what happens when you increase arousal?
the performance gets better.
Yeah, so if you look at the matrix here, when the task was easy, 3, 6, 9. 3, 6, 9. But when the task was difficult, and you go low, moderate, high, what happens there, Drew?
As the task gets more difficult, the performance gets lower.
Not quite. Not if the task is more difficult, but when the task is difficult and you increase arousal, so you'd have to go on the bottom here. As the task is difficult, you go low, moderate, and high. It goes 1, 4, and 1.
Right.
So what happens when the task is difficult when you go from moderate to high arousal?
Sorry. I would say that if the task is difficult, as arousal increases, the performance gets better, but once it goes too high, the performance goes back down to the original lows.
That's right. Performance goes down. So that's kind of the real world statement for the Yerkes-Dodson effect. Now I know we've been really serious here for the first 20-25 minutes of class here. I think it would be wise to end this part of the review and kind of add-on thing by letting you know, number one, when it comes time to the test in 2 weeks, it won't really be a test, but when we have class 2 weeks from now, you'll actually create example data sets and then you'll just do them out. So you'll probably be asked to create a 2-factor ANOVA. You can just, and we'll do it together in the class, and then your homework from that will be the competency, which is where you just write everything up and what it means. I know I'm kind of pushing the limits here, and I do have to end with one hopefully somewhat silly situation here. And I just want to say that the Yerkes-Dodson has not been successfully applied to male sexual functioning. Okay, that'll do it for that.